If you skip a meal, your head can start hurting even before your stomach feels completely empty. And this usually happens because your brain is extremely sensitive to changes in fuel. Most of the cells in your body can switch between different energy sources, but your brain depends heavily on a steady supply of glucose moving through your blood. When you eat carbohydrate to feed brain cells, nerves, and muscles. But when you go too long without eating, the amount of glucose available in your blood can start dropping. At first, your body tries to keep everything stable by releasing stored sugar from your liver. This helps for a while, but if the gap between meals keeps getting longer, your brain begins detecting that fuel is becoming less steady. Even a small dip can matter, because your vision, memory balance, and every signal moving through your body. Once your brain senses low fuel, it starts pushing your body into a stress response. Hormones like adrenaline and cortisol rise to help pull more energy into the bloodstream. These hormones can keep you alert, but they can also make blood vessels tighten and relax in uneven ways. Around the brain and scalp, those changing blood vessels can irritate nearby pain-sensitive nerves. This is one reason a hunger headache can feel like pressure building across your forehead, temples, or the back of your head. Skipping meals can also make your muscles tense without you noticing. When your body is low on fuel, your jaw, neck, shoulders, and scalp muscles may tighten as part of the same stress response. Those tight muscles can pull on tissues around the skull and add more pressure to the headache. If you are also focused on work, school, or a screen, you might clench your jaw or hold your neck still, which makes the pain stronger and harder to ignore. Another problem is that many people drink less when they skip meals. Food normally brings water and salt into your body, and without it, you may become slightly dehydrated. When fluid levels drop, your heart has to work harder to move oxygen and nutrients. Low blood sugar, stress hormones, tense muscles, and dehydration can all stack together. When you finally eat, your body starts reversing the process. Glucose rises back into a steadier range, stress hormones begin calming down, and your brain gets the fuel it was waiting for. If you drink soda too fast, you might suddenly feel a sharp burn shoot up into your nose, and it can feel strange because the soda never really touched the outside of your nose. This happens because your mouth, throat, and nasal cavity are all connected through the back of your airway. When a fizzy drink moves through your mouth, tiny bubbles inside it are releasing carbon dioxide gas. Most of that gas escapes as burps or foam, but some can travel upward toward the soft opening behind your throat. If you swallow, laugh, cough, or breathe at the wrong moment, a small spray of soda or carbon dioxide can get pushed into the space behind your nose. Once it reaches that area, the lining inside your nasal cavity reacts very differently than the lining in your mouth. Your mouth is built to handle strong flavors, acids, and bubbles all the time, but your nasal lining is thinner, wetter, and packed with sensitive nerve endings. It also has a layer of mucus sitting on top of it, which is there to trap dust, germs, and chemicals before they move deeper into your airway. Soda also contains dissolved carbon dioxide, and when that gas mixes with moisture on the surface of your nose, it forms a weak acid called carbonic acid. Even though this acid is not dangerous in a normal sip, it is enough to irritate the delicate tissue inside the nose. At the same time, the bubbles themselves make the feeling sharper. As carbon dioxide escapes from the soda, it creates tiny bursts against the wet nasal surface. These bursts disturb the protective mucus layer that normally keeps the tissue calm and slippery. When that layer is disturbed, acid and gas reach the nerve endings more easily. Those nerves are part of the same warning system that reacts to spicy food, smoke, cold air, and strong smells. They do not know you are just drinking soda. They only detect irritation, pressure, and chemical change. So when the carbonic acid and gas hit them, they send fast warning signals through branches of the trigeminal nerve. This nerve carries sensation from your face, nose, eyes, and mouth, which is why the burn can feel like it spreads upward instead of staying in flat. Your brain receives those sting or burning feeling. Because the nose and eyes share nearby nerve pathways, your eyes may water at the same time. The reaction can also trigger sneezing, because your nose thinks something foreign has entered the airway. That sensousecond is all why soda usually fades, because the soda gets diluted by mucus and swallowed or cleared away. If you stare at a screen for too long, your eyes can start feeling dry, tired, or slightly burning. And this usually happens because your blinking pattern changes without you noticing. Normally, every time you blink, your eyelids spread a thin tear film across the front of your eyes. This film is not just water. It has a smooth oil layer on top, a watery layer in the middle, and a thin mucus layer underneath that helps the tears stick to the surface of the eye. Together, these layers keep the clear front surface smooth, comfortable, and protected from dust and air. When you look at a screen, your brain focuses so hard on the image that your blink rate naturally slows down. You may also start doing incomplete blinks, where the eyelids move but do not fully close. This means the tear film does not get refreshed evenly. Some areas of the eye stay covered, while other tiny patches begin drying out. The longer you stare, the more those exposed patches lose moisture to the air. Because the screen does not move like a normal conversation or outdoor scene, your eyes can stay locked in one position for several minutes without a full blink. At the same time, screens are usually bright, close to your face, and filled with small details that force your eye muscles to keep making tiny focus adjustments. This does not directly dry the eye, but it adds strain, making the dryness feel more noticeable. If you are in a room with air conditioning, a fan, or low humidity, the tear film evaporates even faster. Once the oily top layer becomes uneven, the watery layer underneath disappears more quickly, leaving the surface of the eye less protected. The dry patches can also make light scatter unevenly across the cornea, which is why your vision may look slightly blurry for a moment. The clear front surface of your eye, called the cornea, is packed with sensitive nerve endings. When dry spots form, those nerves start firing warning signals. Your brain reads those signals as dryness, burning, stinging, pressure, or the feeling that something tiny is stuck in your eye. If your fingers get numb in the cold, it is not just because the skin itself is cold. It usually happens because your body is trying to protect the temperature of your core. Your fingers sit far away from your heart, and they have a lot of surface area compared with their size, which means they can lose heat quickly. When cold air touches your hands, temperature sensors in the skin send warning signals to your brain. Your brain reads this as a threat to body heat and starts adjusting blood flow almost immediately. The first major change happens inside the tiny blood vessels in your fingers. These vessels begin to narrow, which is called vasoconstriction. By tightening those vessels, your body sends less warm blood toward the skin and keeps more heat around your chest, abdomen, and vital organs. This is useful for survival, but it means your fingertips get less warm blood, less oxygen, and less fresh energy. As the flow slows down, the skin can turn pale, stiff, or slightly bluish because there is less warm red blood moving close to the surface. At the same time, the nerves in your fingers start working less efficiently. Nerves rely on warmth and steady blood flow to send clean electrical signals. When the tissue gets cold, the chemical reactions inside nerve cells slow down. The nerve endings that normally detect touch, pressure, and pain become less responsive. Instead of sending clear, detailed messages, they start sending weak or delayed signals. Your brain receives less information from the fingertips, so the fingers begin to feel dull, heavy, or numb. Your fingertips are affected faster than many other body parts because they are small and exposed. They do not have much thick muscle or fat to keep. The blood vessels inside them are narrow enough that even a small amount of tightening can make a big difference. If you keep your hands still, the problem gets worse because muscle movement normally helps push blood back through the fingers. Sometimes the numbness comes with tingling or pins and needles. When you warm your hands again, the process reverses. The blood vessels relax and widen, letting warm blood rush back into the fingers. After a few minutes, if you stand for too long, you might notice your legs suddenly start shaking. And this usually happens because your muscles are getting tired. While you're standing still, the muscles in your legs have to keep squeezing over and over. To hold your body upright and stop your knees from collapsing. As they keep working, blood can begin to pool in your lower body. Which means less fresh oxygen reaches the muscles and they start running low on energy. At the same time, waste products begin building up inside the muscle fibers. Making each contraction harder to control. Your nerves then try to keep correcting your balance by sending faster signals to different muscle groups. But once those muscles are fatigued, the signals become less smooth. Instead of one steady contraction, the muscles begin firing in tiny, uneven bursts. This causes the trembling or shaking feeling you see in your thighs or knees. Your calves and thighs may also start tightening because your brain is prioritizing stability over comfort. If you keep standing there, the shaking can get worse until you sit down, move around, or shift your weight, which helps blood flow return and gives your muscles a chance to recover.